This is the schematic for our STM32F401CEU6 based Blackpill board. You can see this is the left connector, this is the right connector. They look like this here. So this one is the left side, this is the right side, and then they will connect it into our board, and then we will have some additional components, like we have 3 LEDs to play with. We have an LCD, like we will be having an onboard LCD. You do not need to wire it up, it will be wired using the PCB. Then these are some additional connectors to have like more 3.3 ground or 5-volt pins to power up the external modules from the STM's power. And then this is an additional power input that will be used to power up the STM32. In case we don't want to power up the board using the STM32's input power, we will use this power. Then this is the PCB layout. Over here you can see the bottom layer is auto generated, auto routed. The top layer we made ourselves, so there are only 3 jumpers. So this is the LCD connector, then this is our inner side. These two are on which our STM32 will be inserted, and these outside will be, like in case of Arduino you have female headers. There you have the 3 LEDs, there you have the input power connector, there you have the extensions to the power connectors. That's it. And this is how the 3D view looks like. There you can see the center one, this and this. On this you will insert your STM32 Blackpill board, and these are the external from where you will draw your female these are the female header from where you will draw your jumper wires, like you want to connect it to external sensors or modules. And then we have an onboard LCD already connected at the bottom. You can see in the schematic the pin selected. Then we have 3 LEDs, they are also on board. You just have to program them, they are already connected. So that is a simple development kit we just built for learning purpose. Guys, welcome to learning microcontrollers. In this video I will show you, I have a STM32 Blackpill board and I want to start a series on that, but it is very difficult to use. Usually it is in a setting that it's difficult to like have used, because it comes with a board and some headers. It looks something like this. You just solder them over here and then you have to use it. But I want a PCB board like a trainer board, so it will make my and your life easy. So for that we will be making a schematic and then a PCB, and then we will be using that board in our rest of our videos. So let's get started. So guys, this over here is the only dimension that is required to make a board. Now what is the distance between this and this connector? That is 15.22 mm. You will need this, like you do not have the footprint I guess directly in the Easy Ada. We are going to use the Easy Ada Pro. You may use a Proteus, Altium, whatever you prefer. I'm going to use the Easy Ada because it's open source, and I also have a lecture on that, how you can download and install this for free, and it's an open source software. You do not need to pay even a penny to use it. Now guys, let's get started. So this is the distance that we needed. So the distance between these two headers is 15.22. Rest, you can see the pins here: 1 2 3 4 5 6 7 8 9 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 here and 20 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. That's all you need. Now let's start designing. So this is the Easy Ada Pro. Let me zoom in so you guys can see better. I use the Windows magnifier to zoom in. So just like always, click on File, New, Project. This window pops up. Write the name of the project. I write STM32 Blackpill board dev kit. So that's all I wrote. Click on Save. Wait. Okay, this window pops up. Here on the left you have this schematic. Double click. This window page pops up. Here you will start making the schematic. Let's first get the headers. You will not get this microcontroller board directly here, so you just get the header. So here you write header. You may use the LCS or Easy Ada tools, both will have the headers. So in the LCSC tools that have big options as compared to Easy Ada tools that has limited options. So remember to keep your software in half on offline mode, so you can have access to the LCSC library. Else you will not have the access to this library, this one, LCSC. So in the Easy Ada library, if you want to go with that or LCSC, whatever you prefer, you may go with whatever you prefer. Okay, now first of all we go there and then we write whatever we want to select. I want to get the headers. So header, okay, there in the LCSC library write header, wait. In the connectors you have the headers female headers. Okay, that is what we want. Okay, then you need a header of 20 pin header, and this one is fine. So this is the standard header with 2.54 pitch. So that is what you get from the market easily. So you need a one with 20 pins, or else you have to connect it. This is an 8 pin, 6 pin. So there you must be having an option of pins. There you go. So there, select the 20 pin. If you have it, then that will be great. Apply. And now to further narrow in the search, you can set the pitch like 2.54 is the standard pitch that we use. So there we go. We already got this. So that is what you need. So you place one here. That is your one side. I call it left side, and this one I call the right side, like this. Okay, or you press X to mirror it like this. So now this will be the STM32's base. Like we will just insert our board on this. The distance will be 15.22. That we will do in the PCB side. So what we want over here is that now we need to connect the nets. So we can like give the names to the wires. So the first one is this on the one on the left. So now this is something technically that you have to understand. Now what I do is that to make my life easy, I just get the new slide. I just copy this because it has a labeling here. I paste it here and I rotate it in a way that it shows this. So I will be making my board like this. Now see this. This is our left header on the easy header, and this is the right one. So it is B12, B13, B14 and B15, the top lines. So I go to the easy header. So here, this is the B12. I name it B12. Okay, remove it, just use this one, the dual one. So we will have same for all of them. So this one is the B12. B13. Then you have B14. Here, just copy paste them, B14, and then B14 and 12, 13, 14, 15. Okay, we also have 15 as well. So it's the next one is the B15 like this. So it's B15 like this. Now go back to the presentation, and the next pins are A8, A9, A10, A11, A12. Okay, just copy paste all four of them like this. This one is A8, A9, A10, then after that A10, I think it's A11 or A15, A11, A12, A15. Okay, A11, A12, copy paste this, and then you have A15 over here. Okay, let me zoom out, it is causing confusion. Okay, this is A15, A15 just like this. So now let's go back. Okay, check here. We have next one is the B3, B4, B5, B6, B7, B8 and B9. Okay, just copy paste them. B3, B4, then we have B5, then we have B6. Okay, B6, and then we have B7, B8 and B9. Copy paste all three of these. B7, B8 and B9, that's all we need. And then we have 5 volt ground and 3.3 volt. Okay, 5 volt, I call it 5V. Then I have ground, I call ground G and D. Oh, sorry, G and D. And then we have 3.3 volt. So for the 3.3, I just use 3V3, that will be fine. Okay, that's all. Now this is our one connector, that is the left one. Now we do the same for the right side. So just copy these, and okay, instead of doing this, I press X. This will like invert the direction like this. Now this is our right side. Now on the right side, the top one is 5 volt ground, 3.3 volt B10. So this is 5V, G and D. Sorry, again G and F I wrote accidentally. This is G and D. This is 3V3, and then after that we have B10, B2, B1 and B0. There, B10, B2, B1 and B0, like this. And then we have A7, A6, A5, A4, A3, A2, A10, A7 to A0. Then start from A7, A6, A5, A4, A3, A2, A1 and finally A0, like this. Then we have reset or C15, C14, C13. Then we have R, sorry, this is the R, C15, C13, C14, like this. And then the last one is the VB. So we have VB. So in this way our connections are completed. We can counter check to make sure that we made no error. So we start B12, B13, B14, B15, B12, B13, B14, B15. Then we have A8, A9, A10, A8 to A12, A8, A9, A10, 11, 12. Then we have A15, then B3 to B9. Then we have A15, B3 to B9, and then we have 5 volt. Then we have 5 volt ground and 3.3. Then we have 5 volt ground and 3.3. Now do the same for the right side, this header. So on the right side, 5 volt ground, 3.3 volt, 5 volt ground, 3.3 volt. Then we have B10, B2, B1, B0, B10, B2, B1, B0. Then we have from A7 to A0, A7 to A0. Okay, then we have R. Then we have R, then we have C15, 14, 13 and VB. C15, 13, 14 and VB. Okay, that's perfect. So this is our board here, right? You can see that it's perfectly fine. Now guys, we have our board base completed. Now we can like connect various components. Now whatever the component you want. Now this is the base on which your microcontroller will lie. Like this over here, once we connect these connectors, then we will like insert it into the space. Now we want another connector to the right. That should be the female connector, in which we will connect the jumper wires as well. So I want that option as well. So I just copy this connector, I paste it like this, and I copy this, I paste it like this, and I just duplicate them. Then in the PCB layout, I will move these to the other side. So I just copy all of these like this, I paste them and connect them here. So this will be the duplicate of this a bit away, and this one will be the duplicate of this a bit away, like this. So we will have the duplicate on the PCB. Once I go to the PCB side, you will understand what I just did here, how much easy it will make our life. So like in case of Arduino, you have a connector on which you connect your jumper wires, the female side. So that's how we are gonna have our board, just like an Arduino. Now what else components do I want here? Like on my board, I want a connector for the LCD. I want to connect an LCD. So since we know that we have LCD connector, let's see, a 16x2 LM016 LCD. That is very common. So we just install a connector for this. We want an onboard LCD. You can say that. So I want an onboard LCD. So to do that, what we need is that I go down, just get the one with the labeling, which one is labeled. Okay, this one is labeled. This is perfect. So here you can see the pin layout. So it is VSS VCC 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 pins. So we need a connector of 16 pin for this. So go back. Now there, instead of going for this, you just set your pin count to 16 instead of 20. Make it 16 if it's available. Else we add like 2 which are not. Okay, this is 8 pin. Okay, no, this is not the one. We want SIP, single inline. So this is the 16 pin. I guess it's 16. Okay, yes, it is 16. That's perfect. So this will be the connector for our LCD. I connect it here. Now sorry, only one is needed for the LCD. So this is the connector for the LCD. I move it so I can have one on this side like this. X mirror is press X. Now the first pin, now let's do the wiring. So you can do the wiring using your this button over here, wire. You just bring it here. So first of all, connect the pin number 1 and 5, common them like this, and then pin number 1 and 5 are common, and this pin number 15 and 16, you have two pins here, and one is the LCD backlight, two are the LCD backlight. The first one, that is the pin number 15, is the LED 5 volt, then next one is a ground. So you also connect that ground as well, common this. 16 is also the ground for the LCD backlight like this. Now this is your ground side, and for the ground side we have this connector, so we have to ground it with our microcontroller, so just connect it like this, so it is grounded. Now pin number 2 is your power pin. You need a 5 volt, so we take the 5 volt from the STM32, this pin. So this is the 5 volt connected here to the pin number 2 like this. So 5 volt is also connected. Just make it look a bit presentable. It looks bad like this. Okay. Now pin number 3 is your contrast adjustment pin. For this you need a potentiometer. So you go there, you write here potentiometer. Or if you know 3296 is a blue part that I usually use. So just write either the variable resistor or the potentiometer, or you may try your luck with 3296 directly here. Let's see, does it able to bring it? Wait. Okay, it is not showing the photo, I can't get it. So we write here variable, so it will bring in some resistors. Okay, resistor, potentiometer, variable resistors. Okay, that's you need. Okay, this is the one we need, so it is perfectly the one we needed, a 10K variable resistor. You will need it, just place it here like this, and you connect the pin number 3 to your potentiometer's adjustable pin. That is the pin like this. Pin number 1 will go to the power, another will go to the ground. So there is the power, either you connect this to the power or this to the power. So I connect it to the power and the other one to the ground. So this is the ground, copy the net. So that is the beauty of using the nets. You do not have to like do all over again everything like this. And now pin number 4 is your reset pin. You may use any available digital input output pin. Now it's up to you, whatever pin you want to use for this. So I select a pin number called B0. So this is B0 pin. I will use the B0 pin for this one. So I connect the B0 to the RS like this, and then okay, again make it look presentable. B0 to the RS, also move it up. Okay, we need to move this whole thing up so we can have better presentable view. Okay, like this. Okay, now the pin number 6 is your enable pin. So for the enable, whatever pin you prefer, you may use it. So you go there, you select a pin. I select B1. So this is the one. So we use the B0 pin for the RS, B1 for the enable like this, and then pin number 7, 8, 9 and 10 are for the pin number D0, D1, D2, D3. They are required for the 4-bit mode, while we are going to use LCD in the they are required for the 8-bit mode, while we are going to use this LCD in the 4-bit mode. So we only need these 4 data pins, D4, D5, D6 and D7. So you can see, let me show you. These are the pins we are going to need, D7, D6, D5, D4. We will abandon D3, D2, D1, D0 because they are required in the 8-bit, while we are going to use LCD in the 4-bit mode. So let's select more pins. So you may use any available digital input output pins. So I have to select the pins myself. So whatever pins I prefer, I will select. So here I select B0, B1 are gone. So I select B2 for the D7 pin. That is pin number 14. That is D7 is B2. Okay, we just go in sequence, that will look fine. So A7 for the D7. Okay, this will be way better. A7 for the D7 pin, this one. Then I select A6, A5, A6. Okay, I think I need to remove the magnifier, it is causing trouble. Like this, okay, this is fine. A6, A5 and A4, okay, that's fine. A6 for the D7, like this, we just move them like this. Okay, this is perfect. A7 for the D7, A6 for the D6, A5 for the D5, A4 for the D4, that's fine. B0 for the RS, B1 for the enable. Now that's all you need. Now this is the LCD backlight. If you do not connect the backlight, your LCD will not glow. To make it glow, you have to connect the pin number 16. Pin number 16 goes to the ground and 15 goes to the 5 volt. So 16 is already grounded, so we need to connect this to the 5 volt, that is pin number 15. Here you go. Now the LCD will glow as well. So our LCD is now connected. So we have a connector for the LCD. So LCD will be inserted into this connector. So that's all we needed. Now guys, the next thing is whatever else components you prefer. So I want an LED as well. So I want like 3-4 LEDs on board to play with them. So I just go there in the tools again. Here I remove this, I write LED, and it shows me various options that what type of LED you want. So in the crystal displays, OLED, no, we do not want these, we don't want these, we don't want these, we don't want these as well. Okay, optoelectronics, the LEDs we want comes under the LED indication, so that's we need. Okay, discrete LEDs, so that's what we just need. So there are various types. We want one with a 5 mm through hole type. So I think they are available or not. Okay, we go to the Easy ADA library. That is smaller, but that's like simple to use. Simple components are better to be used in the selected in the Easy ADA library. So LED again, go to the Opto, and also click on this. This is only in the Easy ADA library. This one that you will be able to 3D print as well. LED and LED discrete components. Okay, that's all we need. Okay, they are not the LEDs we need. We just need these LEDs. LED bulb worker. Okay, whatever it says. Crystal oscillators, LEDs. What is inside it? So just okay. What the most relevant? This is the one I can find is the most relevant option here. So once you click on it, once you click over here on this thing called grid list, then you will see the 3D print here as well. This is the 3D print. You have to click on it. So it looks like this. Just keep checking if you find the one that you need. Okay, let's see what is this. I think my internet is slow. It is downloading something. Close the Steam and the stuff. Okay, it is showing. So this is the SMD. We want a through hole package, this type of package. So let's see what this through. Okay, this shows something relevant. Okay, this is the one we just needed. So this is the LED we need. So we got our LED. So just place your LED wherever you prefer. I like place 3. I will have 3 LEDs. I may use any pin I want. Now I will not connect the LED directly, they may get burned. I will use a grounding resistor. Now again go back. Now you have to get the resistor. Now instead of using this, write resistor, and it will show you the categories. Here you just narrow in your approach, look for a through hole package of this through hole resistor. So this is easy because this is a huge library, so it sometimes is difficult to get your. So this looks big. This has 13 mm pitch. Our resistor is not this big. So this one has how much pitch? No, this is not the one. This one. This also looks, I think, bigger than our normal standard resistor. So this is the one. So just get this, place it here. We will change the value to not change the value. Go to the right, open this property. Here you have the value. So 220 is fine. I make it like 220. That's fine. 220 ohm like this. Now it's 220 ohm. I copy it, paste it here, paste it here. That's what I just need. So there you go. Just okay, instead of doing this, you may just drag it and it will autocorrect. So like this. That is the beauty of Easy ADA. So like this. Now it's connected. Now from this side you may connect it to any pin that you want. So I use the B12 for the first LED, B13 for the second LED, and B14 for the third LED, like this. And from the other side, these 3 will go to the ground. Just short them together like this. And then you use a, oh sorry, I just, okay, like this. Now you use a ground here. This is the ground, your common ground of your microcontroller will be the reference ground, just connect it here. So in this way the LEDs are connected. Now we have the LCD, we have the LEDs. What else component do you want here? So I want a terminal block. Like if I want to power up the circuit using a terminal, like I have 2 wires, 5 volt and ground, then I may use it. So we get the terminal block. I write here terminal like this, and it shows me the various options. This is the terminal block here, or you may select it in the LCSC library. There you have the screw type connector, and that is the terminal block we are talking here. Okay, wait, my internet is slow, else it will not take this much time usually. Okay, industrial connectors or something, terminal blocks. Okay, PCB welding terminal, this terminal, that terminal, square, nickel. Okay, no connectors. Okay, there we go. In the connectors you have this screw terminal block. This is the one we need. So just click on it, and again you click over here. It will show you the 3D view how it looks like. Note this is not the one I usually use, so these are the different one. Just look for the 2-pin one. I want, if you know the specification, you can like add filters to it. I think the standard that I use is like 5 mm pitch, so I make it 5 mm. I apply filters to narrow in, and the one I want right now is 2-pin only. So where is the pins option? There, the 2-pin one. Apply these 2 filters, it will narrow you in to the your list. So let's see. Okay, open the preview. I think internet is slow. Okay, I remove this because I'm not sure about this. I have not like checked it. That okay, this one looks fine to me. Okay, this one, let's see which is this one. Okay, this one is fine. It have the same pitch. Okay, just you paste it, place it wherever you prefer. I place this will be the main power input for me. Like if I want to power up the circuit using this, then I will use this instead of going that. So I connect the 5 volt wire, this wire over here like this, and the other pin I connect to the ground like this, and here you go. This will be our input as well. Now suppose I want to draw the power, I want to give power to the other circuit components using this STM32 kit, and I want more pins. So I add like 3 of these, 1, 2 and 3 there, and then I connect the 3.3 volt pin to the 2, so they will be for the other component. Like I have more component requiring the power, I can just plug those components into these ports. So STM32 will power up those components. So we will have additional 2 grounds to connect additional components. So it will be like this, and then we will also have an additional 5 volt pin. So this will be used to like connect other component working on the 5 volt. So this will be like extension to this port as well, further extension. So we will have these terminals. Okay, that's it. Now we need a capacitor. I want more voltage regulation, although there is voltage regulation on the board, so that's not required. So this is it. This is our simple development kit that we just made. So the next thing is we just go to the PCB side, double click on this PCB layout. Wait, here you have this design, import changes from the schematic. Click on it. This over here are the changes. Click on apply changes. Here you go. The changes have been applied. Okay, there you go. Now what I do is that I simply go to this bar and set the unit to mm. Then I make a box, like whatever the dimension of the box that's available at your place. The board you have, the maximum diameter you want to have, or the length and width of the PCB. So I set the length to be like I can call it like 4 inch, that is 100 mm. Okay, I make it 5 inch, 125 mm long, and width to be 125. So it will be a 4x4 board. That's not a very big board, but it's fine. It will be good for this. Okay, like this. Now I place the components inside. I place the header first. Okay, the first header here, the second header goes here, the third header goes here, just like this, and then we have this header goes here. Then we have the LED and the resistor. So first we set our STM32 board here. So these are the two, you can see that they are like coming in parallel. So these are our STM board's main connectors. So they should be in line with each other. They should be exactly right front of each other to make sure that it gets plugged in easily, like this. See, it's fine. Now I move it down. Now how much away they should be from each other? 15.22 mm, as shown in the presentation. There it is useful. That's why I took this. 15.22 mm is the distance between both the boards, both the connectors. So first you make sure that they are right, they are exactly above each other. Now draw a line. There you go. Here you have this Meyer line, this one, this line. You place it like you connect it here, and you like move it down. Press shift if you want to make it straight. 15.2. So 14, 15.2. Okay, this is 240. It becomes out to be here. Okay, it is 15.240. So further you can also use this line tool as well. Over here, this one, this is the line. Just draw it using this. So I draw it like this. I press shift, and then okay, this is it. Just bring it down and make sure that it's 15 mm. So there is a tolerance, so no need of like going too extreme, like it should be 15.240. It's fine, it will be able to insert it, so that's fine. So here we go. Our STM board will be connected on these headers, so they should be in front of each other. Now if you have still a problem with the dimensions, just you check it, verify it, counter check. Just place it here, press shift. So it's fine, it's 15.2 something. Okay, that's fine. So this is our STM board. That's how we are going to connect it. So the duplicate headers, let's bring in the duplicate headers. So now on these headers the board will be connected. Now that's why we went for the duplicate headers. Okay, there. Okay, okay, there is a mistake here. Now these are the duplicate ones, so it's 15. So it will come at this side. Okay, let's first okay, let's first take it on the, okay, we have already taken the dimensions. So this is one side, just place it right above it like this, then move the bottom one. Okay, 2 times I pressed it. Okay, here you go. Then just 1, 2. So that's at 15.2. So this is a duplicate of the above, like this. It will come here, just like this. So you can like bring it right in front of it. So distance of it from this doesn't matter. It can be as far as you want. Like in case of Arduino, it is on the border side. So we just bring it here and then do the duplication for this the same way, like this. So see, that is the beauty. Else if you didn't did this in the schematic, then you have to do all this wiring yourself. Now like this, it will be connected here, the other side. So on the central one, our STM32 will be connected over here, and on this one, what will be connected is our, this will be like open, a female header on which we can connect anything, just like in case of Arduino, you have a header at the side of the board. So that is how this is going to work. Now over here I can see that this is the power and the ground, so it should be like brought anywhere you prefer. Now let's connect the LCD first, because this component is gonna take a lot of wiring. So it's connected mostly on this side. Okay, that's fine. Then we have a contrast adjustment resistor, there the LCD. Okay, if you connect it here, I think it seems fine to me. LCD will be out of the board. Okay, there the wiring is very shuffled up. So if we rotate it and bring it on this side, you can see whatever side seems to be more easy to connect to. Okay, it seems like this. Okay, we can like bring it up on the board, but it will collide with the STM32 if we are not careful here. So we like connect it like this. Okay, this seems to be way better. So this seems better. So we connect it like this over here. So this is the contrast adjustment resistor. So this is the one. So there is a problem now. Now if one is this side, this means the LCD face will be that side. So we have to like rotate it, press X to X mirror it. So I press X. Where is the mirror? Rotate, flip to opposite side. No, not the rotate, not the flip. It's X mirror. I think X is the key, but why I cannot do it? There might be some other option to mirror it. Mirror. Okay, flip to opposite side. Okay, it's fine. Okay, this will do. This will do exactly fine. But on the 3D model, this will be a problem. So we should not do this. Okay, what I do is that I have to like rotate. Okay, this is fine. Rotation will do fine. So rotation 1 will be this side, so that's fine now. Okay, it's perfectly fine. Rotation have done the job. No need to X mirror. So there we go. We have the LCD to be connected here. So we will be using some jumper wires to make sure that these do not get collided. Or you can also go back and just change these. So 11, 10, 9, 8. So they are coming like this. Okay, no issue. So there will be the contrast adjustment resistor connected over here. So we make it like this. It seems way easier. Okay, we bring it on that side. That will be also better. So this is more better, like over here, easy to connect and stuff. So we have now the LEDs. Bring the LEDs in. So connect the LEDs wherever you prefer. Okay, they are here. Okay, that's fine. They are to be here. Okay, that's perfect. Now guys, this is it. The board already have a lot of component, like it have resistors, capacitor, whatever is needed. Verify the distance, as your STM board will not connect. Again, verify it because we did some changes. Okay, no, it's 12. It's wrong. We have to move it a bit. So to verify that, we get exactly the 15.2. We may use a line as well. Okay, go back. There is a rectangle. I have a hack for this. On the rectangle, you can set the dimension. Just set it to 15.2. That's all. And the other side to just whatever you prefer. I make it like 2 mm. Okay, we have to go the other side. Okay, just rotate it. Now it's exactly 15.2. You just place this here, the corner to be here, hitting the center like this. Now you know this is the 15.2. You have to move these two down to make sure that it's always come in the center. So if it's in the center, that is the 15.2. Now this is the hack. Okay, now you just connect these two together, press shift. Okay, it says 15.11 something. Okay, it's exactly 15.204. That's perfect. So just delete the rectangle. So there we go. The distance is now checked. Also check it on this side as well to make sure that we didn't make any mistake. Okay, in the center. Okay, it shows 15.113. We need 15.2. So I recheck over here as well. There should be no problem with the dimensions, as your board will not work. Okay, it's 15.113. We need to move it a little bit down. So now we check again. Okay, 15.240. That's perfect. That's fine. That's a grid allows. Okay, that's fine. 15.240. It should be the same over here. So 15.240. That's fine. So the dimension is fine. There we have the 3 LEDs. So I move them a bit far away. They are too close. Okay, let's move them little bit away from each other like this, because we have a lot of space. Now a lot of board is left, so you may like now shorter the board because you do not need this much space on the board. So over there, if you have a problem, like this one seems to be better at this side, and this one should be in the center, this one should be on the right. Okay, like this for easy auto routing. So this seems better. And also we can move it bit close to the board. Sorry, just move it close to the board a bit because it seems to be possible like this. Do it if it's possible. Here you go. Now there it seems like it should be like this. Then do it, because the thing that matters is the footprint. So it is, this is also not an issue. So we just make it this way, like this. So it seems fine. Okay, this is fine. Okay, this will be the input connector. So this board is also left. Let's just bring it closer so we do not waste the board a lot. So LCD will be in the air. It will not be touching the board. So you can also like move this connector up like this. Also this connector can go this side, doesn't matter, or you can also rotate it if a lot of wiring do not pass it through it, but it's better you keep it simple if possible, like this. Okay, this is better. This is way better. Okay, that's it. If we need little bit of jumpers, we will use them. That's all we need. So this is what this development kit will be like. So let me bring it closer. Now we do the routing. So go to the route. There you have the auto routing. In the auto routing, go to your say there, and I only want the bottom layer to be done. I will do the top layer myself. So speed first is the priority. Go to the design rule, set the tracks, like how much distance they should have from the tracks. I make it 0.3. SMD pad, we don't have any through pads. I want it to be 0.3. Like the routing should be 0.3, should keep a distance of 0.3 mm from the through pad. Via through points, I want it to be 0.3, A2 0.3. So through pad, it will be 0.3. It will be 0.3, and fill region, I want it to be 0.3. That's fine. Again 0.3, 0.3, 0.3. Slot region, line text, board outline, hole. Okay, hole is important. 0.3. I want it 0.3, 0.3 mm distance to be kept between the hole and the wire passing through it. And also we will set the dimension of the wire, because I am going to manufacture it by my hand, so I have to change the thickness of the line. So in the track you have this line thickness. I want the line to be like 0.7 mm. So okay, no, this is not the thickness. Okay, I think it was 0.254. That's fine. Okay, this is the thickness. I want it to be 0.7 mm or 0.75 mm. That's fine. I apply, confirm, and speed first. I click on run. Okay, the auto router is running. Wait. Okay, it's done. Only one wire is left, so we will attach a jumper here. Also do the setting. Like it should not be like this, because I'm going to hand manufacture it. I have to make sure that your manufacturing method should be kept into mind while doing these things, like how you're going to manufacture it. If you're going to get to manufacture from the from some professional, then no issue. Just ask him whatever the design rules he gives you. So that's all. So here the design rules. Here you go. B0. Okay, now see, these are the beauty of design rule. If it didn't set the design rule, then it was to go too close, and I was not to be able to manufacture it. So let's do some changes, because the line is passing to be too near to something all the time. So this seems better. Now it is away from here, also away from here. Also this 5-volt wire is going too near the okay, this is fine, seems nice. Okay, nice and good. Okay, now two wires for which we need the top layer. Now just go to this wiring and you draw the top layer here. Here you go, top layer for this, because it is failed to do the routing. Okay, so first just go to the bottom layer, double click. Now this is the bottom layer on which we are now. Delete this, go back, wire it up, just move it from here, and just double click to go to the top layer through a through point. We will just connect a jumper here, because little bit of jumper doesn't matter. If you have a dual layered board, then that will be your top layer. Now this one and this one is also left, just connect it here. Now double click to go to the other layer, double click again, go back to the bottom layer, just connect it over here like this. Now they are connected. Now this wire needs to be connected over here as well. So this is the same wire, you just bring it out here, double click, go to the top layer, and then double click and go to the bottom, and that is, there you go. So no wire is left. This is our PCB layout. Before we end, let me show you the 3D view. Click on this 3D. This will show you the 3D view of the same. Okay, this is how our board is gonna look like. See, this is the view. Now there we have the 3 LEDs. This is our LCD connector, and let me change the view. The top view, see, this is the LCD connector. There your Blackpill board will be inserted on this side. The Blackpill board will be inserted here. These are the 3 LEDs connected to the pins, and these are our 3 top layers values. You may use either a jumper wire, or if you have a top layer board, you just use the board, and there your LCD will be connected. So that is how this board is gonna look like. You can write anything on it as well if you want. So this is how it's gonna look like from the top, from the left, from the right, and the side view. And this is the bottom view. That is our wiring, and this is our top view. That's it. So guys, this is it. If you have any questions, you may ask. So we'll see you in the next video. So goodbye until then. So we will be using this board in our future videos as well. So goodbye until then.